Welcome to Algeomalist Prep Academy. The lesson for today is finding the area between two curves.
The formula for finding the area between two curves with respect to x is the integral of the top function minus the bottom function from a to b, and the formula for finding the area with respect to y is the right function minus the left function from a to b. For our first problem, we're going to find the area between the two curves f of x equals 1/2 x and g of x equals the square root of x with respect to x. First, we're going to make a graph to visualize our two functions. Our two functions intersect at the origin as well as the point 4, 2. We will use these two intersection points as the bounds for the area that we're finding between the two curves. We can also set the two functions equal to each other in order to find the x value in which the two functions intersect. Now we're going to set up our integral to find the area between these two curves. From the graph we can see that g of x will be our top function and f of x will be our bottom function. At this point we are going to plug in the actual functions into the formula. When we find the integral of the square root of x minus 1/2 x from 0 to 4, we find that the area is 1.3333 repeating.
Problem 2. Find the area between y equals x minus 1, y equals the square root of x minus 3, y equals 0, and y equals 1.
In this problem, we can solve for the area in two different ways. First, we will try to solve in respects to x. Let's graph the function in accordance to the bounds given. From this, we can tell to solve in respects to x, we have to divide the area into 3 sections to get top minus bottom. Now, using the knowledge we gained from the graph, let's plug in the values to the formula. From 1 to 2, the top is y equals x minus 1 subtracted by the bottom, which is 0. From 2 to 3, the top is 1 while the bottom is 0. From 3 to 4, the top is 1 while the bottom is y equals the root of x minus 3. By using a calculator, solve each integration and then add them all together to get the total area. Now that we have found the answer, there is another way of getting that same answer in a smaller amount of time and in a simpler way. Let's solve in respects to y. First, let's change the functions from y equals equations to x equals equations. Since we already drew the graph, we can use it as reference for visualization. Since this is in respects to y, we basically flip the graph so that the y-axis is where the x-axis used to be. Basically, this is right to left. Now we can see that x equals y squared plus 3 is the top, and x equals y plus 1 is the bottom. Finally, let's plug it into the formula. Use the calculator to integrate and solve. We can see that both methods get the same answer, but by placing this problem in respects to y, we have less work. Problem 3. Find the area between y equals sine x and y equals negative cosine x in the bounds 0 is less than equal to x, which is less than equal to pi. Since we know the graph of sine and cosine oscillate, it helps us know that they will most likely cross at some point. First, let's graph the function in the bounds. To find the intersecting point of the graph, set the functions equal to each other and solve for x. The only point sine x and negative cosine x intersect in the bounds is at x is equal to 3 pi over 4. Now that we have all the points, let's get ready to plug it into the formula. By the help of the graph, we are able to visualize the areas we are calculating. Now we can plug it into the formula. From 0 to 3 pi over 4, y equals sine x is the top and y equals negative cosine x is the bottom. From 3 pi over 4 to pi, y equals negative cosine x is the top and y equals sine x is the bottom. Now, finally, we can calculate the area by integrating with a calculator. When calculating, never estimate until the final answer, and always go 3 numbers after the dot to get your final estimate.
Thank you for watching Algeomila's Prep Academy. Make sure to like and subscribe.